Welcome students. Today we'll start a new chapter, chapter 4, motion in plane. So we'll discuss scalars and vectors. What are scalar quantities? The physical quantities which have only magnitude and no direction. Example, mass, volume, density, time, temperature, electric current. Now, scalar quantities are those physical quantities which have only the numerical value, your magnitude, and they don't have any direction, like your mass, your volume, your density. They all have the numerical value and the SI unit, but they don't need time, or sorry, they don't need direction. Such quantities are known as your scalar quantities. Let's move on to the next one. Vector quantities. The physical quantities which have both magnitude and direction and obey the laws of vector. Now all those physical quantities which have both the magnitude, your numerical value, and the direction, in which direction they are moving or in which direction they will give the change, these quantities or such physical quantities are known as your vector quantities. Examples: displacement, velocity, force, momentum. Now we will learn how to draw a vector or how to represent a vector. Representation of vectors. A vector quantity is represented by a straight line with an arrowhead over it. So if you have a vector quantity, we generally denote it with a arrow. Now the length of the arrow determines the magnitude. The more the magnitude value, the longer will be the arrow. The shorter the magnitude, the shorter will be the arrow. Now the arrowhead determines the direction, in which direction your vector is moving or in which direction your vector change is going to take place. In our case, it is from west to east. Now, this part of the vector, the origin or from where it is moving, is known as your tail, and this part of the vector, the head part or the arrowhead part, or where it is heading to, is known as head. Fine. Next is your position vector. A vector which gives position of an object with reference to the origin of a coordinate system. So what is a coordinate system? This is your coordinate system. This is your x-axis. This is your y-axis. Now in this coordinate system, let us say you have a point A. This A's position is 2, 3. That means 2 along the x-axis and 3 along the y-axis. So the position of A is 2, 3. So what does your position vector denotes? It denotes the position of A with respect to the origin O. So this blue vector represents your position vector, and how we write O A bar, or you can say O A vector. Let's move on to displacement vector. It is a vector which tells how much and in which direction an object has changed its position in a given time interval. So if this is your position P1, Fine. And we denote it with a position vector r bar at time t1. Position p1. After some time, what happens? This object changes its position to p2. So we denote it with another position vector r bar at time t2. So this is your position p2. Now the displacement vector generally tells us how much the body has moved. It has moved from p1 to p2, and in which direction it has moved. It has moved in this direction, and in which time interval. It has moved from t1 to t2. Fine. So under the time interval t1 to t2, this vector, can you see? This is my displacement vector, which is denoted by delta r vector. And what is delta r vector? I can also write it as the difference of position vector at time t2 minus the position vector at time t1. Right? It will be more clear when we solve some numericals based on this topic. Now let's move on to vector addition. Starting with triangle law of vector addition. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, then their resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. So what does this law say? It states that if two vectors represent the side of a triangle, then the third side will represent the resultant, or it will represent the result of the two vectors. So let us say you have a vector A and you have another vector B. Now we will adjust our vector in such a manner that they form the two sides, or they resemble the two sides of a triangle. So let us first move our vector A. Now let's move our vector B. Now we will adjust the position of the vectors unless and until a point reaches where they are in the same order, means the head of one vector falls on the tail of the other vector. Fine? Something like this. Okay, so this is the two vectors which represents the two sides of the triangle. So the third side of the triangle will represent the resultant vector. What is the resultant vector? The resultant vector is the net effect of these two vectors in the given direction, and the direction will be in this one. Fine. So if this is your A vector and this is your B vector, then the resultant vector R vector equals to sum of A vector and sum of B vector. Fine. Now let's move on to another law. Your parallelogram law of vector addition. If two vectors can be represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a common point, then their resultant is completely represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. Now, what does this law states? If the two sides or if the two vectors represent two sides of parallelogram, then the diagonal of that parallelogram will represent the resultant of the vector. Let's take a look. Suppose this is your vector A and this is your vector B. Now let us adjust these two vectors, starting with A. Fine. Now we will adjust the vectors in such a manner that these two vectors have a common point. This point. This is the common point for your vector A. Now I have represented my two vectors as the two sides of the parallelogram. Now what I'll do is I will complete the parallelogram. Now first let us draw a vector, or let us first draw a side parallel to A, this dotted line. Next, let's complete the parallelogram by drawing another side parallel to B, this one. Fine. So if the two sides, or if two vectors represents the two sides of the parallelogram, then the diagonal of the parallelogram will represent the resultant of the two vectors. Note that the diagonal is drawn from that common point. In this case, all of them have the common tail. Fine. So if this is your vector A and this is your vector B, then your diagonal or your resultant vector R vector equals to A vector plus B vector. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I can re-explain it to you again. So thank you.